There are several ways to format strings in Python, but today's video will be focusing on f-strings, which were added in version 3.6. Formatted string literals, or f-strings, are created by putting an f in front of a string literal. The difference between an f-string and a regular string literal is that f-strings can contain replacement fields. These replacement fields are indicated by curly braces inside the string literal. There can be multiple replacement fields, and they will be evaluated in the order they appear from left to right. If you want curly braces inside your f-string without it turning into a replacement field, you can use double curly braces. You also can't use the same type of quotes inside of a replacement field. This is because Python won't know whether you're trying to close your f-string or open a new string literal. To get around this, you can use double quotes for your f-strings and single quotes for your nested string literals, or the other way around. You can also assign the nested string literals to temporary variables beforehand. Replacement fields are set in three parts: the expression, the conversion, and the format. The expression part is required to make a valid replacement field, while the conversion and format parts are not. I'll cover all three parts in today's video, but I'll start with the expression. Expressions in f-strings are treated mostly like regular Python expressions, with a few notable differences. For one, line breaks, comments, and backslashes are not allowed anywhere in the expression. Additionally, lambda and assignment expressions must be surrounded by parentheses. An expression can just be a variable, like this. Or it can be a complex one-liner you wrote for code golf. It really doesn't matter, as long as it's an expression that abides by those rules I mentioned earlier. You can also put an equal sign at the end of the expression to show the expression next to the value. This is especially useful for debug or logging output, where you have multiple variables that you need to compare. The conversion field is real simple. It's just an exclamation point, or a bang, followed by an S, an R, or an A. These will call the string, represent, and ASCII functions respectively. String will request the string representation of an object. Represent will get how the object is actually represented. And ASCII will convert any non-ASCII characters to an escape sequence. Next up is the format specifier. This is the general structure of the format spec mini language. Don't worry if that looks a bit complex, we'll go through it step by step. It's also worth noting that you can put replacement fields anywhere inside of this section. The width is the minimum amount of characters that the content is allowed to take up. If the content length exceeds this width, it will ignore it, as it is only a minimum. The alignment is the side that the content will be aligned to in the given space. Of course, this will only do anything if the width you've specified is larger than the length of the content itself. Almost everything defaults to being left aligned, except for numbers, which will default to being right aligned. You can use a left angle bracket to represent left aligned, a right angle bracket to represent right aligned, a caret to represent center aligned, or an equals sign. The equals alignment is only valid for numbers, and it works by putting the fill character after the sign but before the digits. The fill character goes immediately before the alignment, and an important note is that you will need an alignment if you're going to use a fill character. This is what the rest of the space left by the width will be taken up by. As an aside, putting 0 directly before the width will set the align to equals and the fill to 0. This is useful if you want your numbers formatted to a certain width, but you don't want all the white space. This can be overridden by putting a new alignment to the left, and then a new fill if you want to, but there's not really much point in doing that. The sign mode is only applicable to numbers. It determines how positive and negative numbers are represented, and has three options. The first is a plus sign. This will force the sign to be shown on positive and negative numbers. The next is the minus symbol. This will only show the sign on negative numbers. This is also the default. The last option is a white space. This will put a minus sign in front of the negative numbers, but leave a space where the sign would be for positive numbers. The grouping option is just an underscore or a comma, which will be used for the thousands separator. Next up is precision, which is preceded by a dot. For strings, this will be the maximum size of the content that it displays. As an example, it can be used in combination with width to specify the exact size of the content that you're trying to display. This might be useful if you're trying to design cells in a table or something. Note that it will always cut off the right side of the string, even if a different alignment is specified. For floating point numbers, it will determine how many digits are displayed after the decimal point if you're using the F presentation type, or how many total digits are displayed if you're using the G presentation type. The presentation type basically determines how the content is displayed and has different options based on the data type. For strings, there's only one and it's S. It's also the default, so it can be left out. For integers, there's a few more. B is binary, so it'll provide the output in base 2. O is octal, and it'll provide the output in base 8. D is decimal, it'll provide the output in base 10, which is also the default. X is hexadecimal, which will provide the output in base 16. If you use a lowercase x, then the letters will be lowercase, and if you use a capital X, then the letters will be uppercase. C is character, it'll provide the corresponding Unicode character. And N is number, which is the same as D, but will use your locale to choose which thousands separator to use and which decimal point character to use. There are also some for floats. Integers can be formatted with these as well. If you use a float presentation type on an integer, it will be implicitly converted to float using the float function. E is exponential notation, and it will provide the number in scientific notation using e for the exponent. If you use a capital E, then a corresponding capital E will be used for the exponent. F is for fixed point notation. It'll provide the value as a fixed point number to a default of 6 decimal places, or the precision specified. It will use the relevant capitalization for NaN and infinity. A percent sign will give you a percentage. It multiplies the number by 100 and then displays it in fixed point format with a trailing percentage sign. G is general format. It'll round the number to 6 significant figures, or the precision specified, and then provide the number in fixed point notation or exponent notation depending on how large or small it is. You can read up on this a little bit more in depth in the documentation, which is linked in the description. Like the others, the capitalization of G will affect the capitalization of infinity and NaN. N is number. It's the same as G, but it will use locale-based thousands and decimal separators. This is similar to the integer n. The default is similar to G, but will force one decimal place if using fixed point notation. The final format option is hash. Hash will switch to the alternate form of the value, which is defined differently depending on the type. For integers using the binary, octal, or hexadecimal presentation type, the alternate form will add the 0b, 0o, or 0x prefix respectively. For float, complex, and decimal types, the alternate form will force a decimal point, even if it isn't followed by any digits. Also, if it uses the G presentation type, or none, it will add zeros after the decimal to reach the precision. A somewhat important note is that the conversion is calculated before the format. This means the format is done on the converted value, not the original. So that's really about it for f-strings in Python. If I missed anything or if you have something to add, then please let me know in the comments. And other than that, thanks for watching.